better your knowledge of circles, the easier maths will become for you. So let's make sure first of all we understand and are familiar with the main features of a circle. First one to remember is the circumference of the circle. The circumference is just the perimeter of the circle. If you put a bit of string around the outside and measured it, that would be the circumference. Then of course we have the centre of the circle. You usually need to know where the centre is to measure diameters and radii, so the centre is quite important. The diameter is a line that goes across the circle from one side to the other through the centre, and a radius is any line that goes from the centre and touches the circumference, and that's half a diameter. The area of a circle is the flat surface bounded by the circumference, so the red area you see there. At the very least, you must be able to understand what these features are, you must be familiar with them and how they relate to each other, and you must be able to draw them on any circle. For students who are studying higher level maths, there are a number of other features of the circle that you need to be aware of, although there's no reason for all students not to know what these things are. So let's start with a chord. And a chord is any line that goes from one part on the circumference to another. So a chord can be drawn anywhere on the circle, and you will notice that a diameter is also a chord. It's just a special kind of chord that goes through the centre of the circle as well. An arc is any line on the circumference that can be drawn between two radii, so it's part of the circumference. A tangent is a line that is drawn outside the circle but touches the circle in one place only. You can imagine this like a ruler resting on a football. It touches the football in one place. And finally we have a sector. A sector is an area of the circle that is bound by two radii. So it's a bit like a segment of an orange, or a piece of Trivial Pursuit pie. Let's now look at how some of these things relate to each other. First of all, the circumference of a circle. We can calculate the circumference of a circle using the diameter, and it uses a formula that is the circumference, which we're calling c, is equal to 3.141592, and that number continues, times the diameter. That number is a special number that we call pi, and we use a special symbol to represent that number. It's a bit like two straight lines with a line over the top of it. You'll get used to that. That symbol crops up all over the place in mathematics, so do try and remember it. So we can write that the circumference is equal to pi times the diameter, or c equals pi d. You're going to use that equation a lot over the time you're doing maths, so do try and remember it. So for any circle with a diameter of 10 centimeters, the circumference is pi times 10, or to one significant place, 31.4 centimeters. The diameter of a circle is equal to 2 times the radius of the circle. So if we take that formula, the circumference is equal to pi times the diameter, we can rewrite this as 2 times pi times r. That's replacing the d with 2 lots of r. And you probably might end up being more familiar with this particular equation. The circumference is equal to 2 pi r. So a very quick example here. If we've got a circle of radius 8 centimeters, the circumference is 2 times pi times 8, or 16 pi. Unless we are asked for a numerical answer, it's always best to leave the answer in this form with pi in it. It's the most accurate way of representing the answer. That's the perimeter of the circle. Let's move on to the area. To calculate the area of a circle, we also are going to use pi. This time, the formula is going to be based on the radius of the circle. And the formula is that the area is equal to pi times r squared. So pi times r times r. we write pi r squared. So the area of a circle is equal to pi r squared. I'm saying it a lot of times because the more you hear it, the more you say it yourself, the more likely it is that you'll remember it. And this is one that you really are going to have to remember because you'll use it an awful lot. So one last time, all together now, pi r squared is the area of a circle. An example, radius 5 centimeters, the area is pi times 5 squared, and that's 25 pi centimeters squared. Now that formula's come kind of out of thin air, really, and whilst you don't have to know the proof in order to do GCSE maths, I think it's quite interesting to see how it arose. Let's take a circle, and we're going to surround it by a polygon. We're going to start with a hexagon here, and then if we look at that hexagon, we can divide the hexagon up into 6 triangles. And we're going to use that triangle, OAB, as the basis of how we work out the area, first of all, of the hexagon, or the polygon, and then apply it to the circle. The height of that triangle is r, because r is the radius. So O to the base there is O down to the circumference, and that's a radius. So the base of OAB is a length AB. So the perimeter of the hexagon is 6 lots of AB. The area of the hexagon is 6 lots of the triangle area. And the triangle area is a half times the height times AB. So we can say that the area of the hexagon is a half times r times 6AB, and that's a half times r times the perimeter of the hexagon. We've gone through that quite quickly, so if you're not quite sure of how we got there, just go backwards through the video and watch it again until you are sure that that area that we've worked out for the hexagon is correct. But the key there is replacing one part of it with the perimeter. Now you can see that the hexagon, the area, is slightly larger than the area of the circle. And can you also see that if we increase the number of sides of the polygon, we'll still be able to work out the area of the polygon in the same way, which is by dividing it up into a large number of triangles, ever larger number of triangles. But as we increase the number of sides on the polygon, the area of the polygon will get closer and closer to being the same area as the circle. And if we increase it to have an infinite number of sides, we would say that it's going to be exactly the same as the area of the circle. But as we increase the number of sides of the polygon, the length AB gets shorter and shorter, but the perimeter of the polygon will get closer and closer to being the perimeter of the circle. And the more we increase the number of sides of the polygon, the closer the perimeter will get to that of the circle, and the closer it will become to the value we have for the circle, which is 2 pi r. So we can replace the perimeter in the equation there with the value 2 pi r, and therefore that gives us an area of that polygon of a half times r times 2 pi r, and as the number of sides of the polygon gets close to infinity, then the area of the polygon becomes equal to the area of the circle. And if we reorganize that equation, we get the equation pi r squared. So pi r squared is the area of the infinite-sided polygon, which is, as the number of sides becomes infinite, is the same as the area of the circle. As I said, you don't have to know that proof. I think it's quite useful for you to have seen it, to see that the equation for the area of a circle hasn't come out of thin air. But you do have to remember that equation, pi r squared is the area of the circle, and you do have to remember that the circumference of a circle is 2 pi r.